Good evening, everybody. My name is Bert Dicht. I am the Managing Director of Membership for the National Space Society. And on behalf of Larry Ahern, Vice President of Chapters, I'd like to welcome you to our final Space Forum for the year, a fun one, our 2022 Space Year in Review. As always, we'd like to just go through a little bit of our online etiquette. So again, welcome. We appreciate you joining us and hope you'll enjoy the session this evening. As always, I do discuss a little bit about how to answer questions. I'll talk about that in a second. A few NSS announcements, some upcoming space forums. We've got a pretty good schedule in the works for you for 2023, and then we're going to get right into our program. As always with the virtual etiquette, if you would like to submit a question, use the Q&A function. That's best because that goes right to the panelists. There's nothing else that is mixed in with that, and it's easy to pick out the questions that they can answer. We do have a number of questions that were submitted beforehand. We'll try to get to as many of those as possible as well. And feel free, again, to use the chat function, but encourage everybody to be respectful as everyone can see that, and be respectful of the panelists and the audience if you do ask a question or make any comments. As always, we'd like to encourage you to give to our cause. If you're enjoying the programming, like these space forums, I encourage you to support NSS with a donation. I'll thank you in advance for your membership already, and we appreciate all the donations that help us put on these programs. And I will put that into the chat, that link as well. Also, don't forget to do the post-Space Forum survey. It only takes a few minutes to complete. It's completely anonymous, and your feedback is very helpful in planning future events and future activities. A couple things that are coming up. First, a special announcement and a special invitation for the very last breakfast on the moon. This is an event that's sponsored by the National Space Society Chapters Assembly and the Sacramento L5 Society. It's this Saturday. Starts at 7 a.m. Pacific Standard Time, and the special guest is Jerry Griffin, the lead flight director for Apollo 12, Apollo 15, and Apollo 17. So help us celebrate the 50th anniversary of Apollo 17 and the end of our moon shots. I will put the registration link into the chat. You do have to register beforehand. The seating is limited, so make sure you do that, and I know you will enjoy the session. I've been on a couple of those, and they're really very informative. And again, make sure you do register for that. Coming up, we've got a number of things. We're really working to give us a long-range schedule so that you can plan ahead. And we're working on a number of things. I will preface this by saying things are still in work, so the schedule could change. But coming up in January 12th will be our first Space Forum of the year. It will be a discussion about commercial low Earth orbit space stations and NASA commercial low Earth orbit destination programs. And it's going to be sponsored by our space ambassadors. So we're going to have a panel of 5 great speakers to talk about that. And I think you're going to hear a little bit more about that later. Still working on January 26th. We did have one of our speakers had to cancel because of a trip that came up. So we're working to get that replacement in there. On the 9th of February, we have 200 years of space tourism with Bill Bradshaw. You might remember Bill did a great presentation a couple of years ago about space stations in popular culture. So we're looking forward to that. On the 23rd, we've got our Space Health Contest winner, Dr. Maria Kuhlman, who talking about a healthy space. On March 9th, we have Christina Korp talking about space for a better world. And if you look down, you'll see quite a few people we've got in the queue. We have to work on getting the dates lined up, but Grant Anderson will be talking about life support. Peter Garrettson will be talking about space security. We have Erin McDonald, who is the science advisor for Star Trek, and she'll be talking about the science of Star Trek. Larry Bradley, who is an astronaut scholarship foundation winner, works for the Space Telescope Institute, and he'll be talking about the Webb Space Telescope and the results. And two photographers, you've probably seen some of their work that has been in Ad Astra, Mark and Tom Usick, and they're going to be talking about space launch photography through the years. So we're going to try to get all of them into the queue. So it's an exciting time for us as we move into 2023. So now I want to get right into our program. First, I'm going to just introduce our moderator for this evening, Jim Plaxco, who you know very well. Jim is the president of the Chicago Society for Space Studies. He is a digital artist and computing professional. He has done a lot of different jobs for the National Space Society, being both a director and a VP of the Space Society of NSS. And he also has a very accomplished speaker in his own right as a space ambassador. So, Jim, I'm going to turn everything over to you now to introduce our guest speaker.
Great. Thank you, Bert. And I will ask people to bear with me for a moment while I introduce you to the Chicago Society for Space Studies, an organization I'm very proud to be president of, especially since we, CSSS, are one of the oldest space advocacy organizations in the world. We actually predate the National Space Society. And 2022 was a pretty good year for us. We won the NSS Chapter Excellence Award. We were a sponsor of the Students for the Exploration and Development of Space Vision Conference, which was held here at the University of Chicago. We participated in the Alliance for Space Development's March Storm and had a number of space policy meetings with legislators. And we had some pretty good speakers at our chapter meetings this year. If you're in the Chicagoland area, I would encourage you to consider becoming a member of Chicago Society for Space Studies. And if not that, we have a free newsletter that comes out quarterly that alerts people to our various activities. And our primary outreach tool for the last decade plus has been our Speakers Bureau. We have a very active Speakers Bureau giving a lot of presentations on a wide variety of subjects at a pretty wide variety of venues. And we're very proud of our Speakers Bureau. And in the vein of speakers, we've had our leadership doing presentations for decades now. And I believe that Larry Boyle, who currently serves as vice president of CSSS, has been giving this presentation for 40-odd years. And Larry, I got to say, it's a shame because I would love to go back and compare, one of your presentations from, let's say, the late 70s, early 80s about what was happening in space at that point in time with what is going on today, which seems to me to be a much richer environment. So because I want to hear what Larry has to say, I'm going to shut up now and turn the microphone over to Larry. So Mr. Boyle, take it away.
Okay. Let me get my screen share up. So, as Jim mentioned, I've been giving this Space Year in Review in the Chicago area to the Chicago Society for Space Studies and other chapters of the National Space Society. And this is the 40th year. And for my own personal peace of mind, let's not mention that again very much. Okay, there we go. Now there are 72 space programs from the nation in the nations of the world. Most of them are fairly small, and there are also hundreds of private space companies. A lot of them are also small, and some of them are fairly large. There are big programs in the United States, Russia, China, Japan, India, and in the European Space Agency. The estimates are that about $430 to $450 billion is spent each year on space. We have to give that much of a range because a lot of the programs have military components, and those military components really don't publish their data very much. And it's really hard to get an exact handle on just how much the total spending is, but it is around 450 billion or so. Moving to the biggest of those programs, that's the program of the United States. And this has two components, as do many of the major programs. One is NASA, which spends $24 billion a year. And it is very open about what it spends and how much. And then we have the military side, which publicly admits to spending about $15 billion a year. But everybody knows and realizes that there is more spent in the black budget, enough to put it beyond what NASA spends. So it comes into around $50 billion by the United States government in space. And because of the military secrecy, it can't be any more precise than around. Moving to the one that we have the most information about, and that's NASA, with its $24 billion a year spent. And in fact, NASA did get $24 billion in this fiscal year, which actually ends in October of 2023. It's a federal budgeting quirk. NASA has announced, actually at the International Space Development Conference, that it will be re-examining space-based solar power, which was very big in the 70s and early 80s when we first founded both the Chicago Society and the National Space Society. And now they're going to be looking and seeing how the technology has changed and how it might make it cheaper to do. But the main focus for NASA is the International Space Station, and has been for many years now. And probably the biggest problem with the ISS has to do with the war in the Ukraine. And we'll be discussing that a little later in the Russia section. But through the year, the NASA has been operating the space station as it usually has been doing for many years now. And one of the problems that they had this year was actually with water leaks in the spacesuits. When the astronauts went out to do spacewalks, they actually started some of the water that was circulating to keep them environment stable started to leak out, and they were having the water coming up beyond their face. The basic reason for this is that the spacesuits are old. They really haven't been replaced in a long time. And NASA is moving to buy new ones, but they seem to have patched up the old ones, at least for the moment. The first Native American astronaut actually went into space just in October of last year and is now aboard the International Space Station. One thing that really caught the attention of at least some of the people in the space community is they finally got the Boeing Starliner into orbit and to dock to the space station. When NASA set up the Commercial Crew Program several years ago, they did not want to be dependent on a single provider. So they made two contracts, one with SpaceX, which turned into the Crew Dragon, which has been operating now for a couple of years and doing quite well. And the other was for Boeing for what they call their Starliner. And you can see this is just a diagram, shows you what it looks like. And they've had a lot of problems getting this up, but they did finally get an unmanned version attached to the International Space Station in May of this year. This is just a crash test dummy here to test out the seats. And there was also an announcement at the beginning or the end of last year that the IS operations are going to be extended to 2030. So at least the United States is committed to doing 2030. And there's some of the others, like the Europeans, are now on board with that. But this raises the question, what happens after the ISS? And NASA has laid out some transition plans, and those plans involve private space stations where NASA would be the anchor tenant. And you should turn into next month's forum to get more details on that. And as NASA is saying, we're going to have to deorbit. Now, the ISS is very large, a couple of football fields, many tons, and they have to start planning this early to be able to get it safely down into the an empty part of the ocean. This is just a picture of one of their supply vehicles going down. The other part of the American manned space program is the Artemis program. And this is designed to put American astronauts back on the surface of the moon after more than 50 years. And the reason they chose the name Artemis is that in Greek mythology, the god Apollo had a twin sister named Artemis. And since this is bringing astronauts, American astronauts back to the surface of the moon, they thought it was an appropriate name. And this is the plan for getting astronauts back into the moon sometime in 2025, maybe a little later. The Artemis 1 is actually now in space. It was launched late last month, and it's now heading back to the Earth in an unmanned capsule, which will be landing in December 11th. And then in a couple of years, in 2024, they will do an Artemis 2, which is basically a duplicate of Artemis 1, except that this time they're actually going to have a crew aboard the Orion capsule. And then the Artemis 3 in 2025 will actually be sending astronauts to the surface of the moon for the first time. This year, they began to pick out exactly where that landing site would be. They plan to land somewhere near the south pole of the moon. And there are, as you can see, several different possibilities. And in the coming years, they will narrow it down to one that they will actually use. So until this year, the only pictures we had of the system that's going to get us back to the moon, the Space Launch System and the Orion capsule, were some nice artist conceptions like this. And NASA planned to get the first unmanned test this year. And they did have some problems. They started in April trying to get a launch, but they had some technical difficulties. It was the first launch. There's always some teething problems with these sorts of things. And they actually did try again in September, but finally in November of last month, they did manage to launch the unmanned Artemis and the Orion capsule toward the moon. And as I said, they now have gone around the moon and are coming back toward the Earth for a landing on December 11th. They also tested a small capsule called Capstone, which was designed to test the access to the lunar near rectilinear halo orbit. That's a fancy name for a special orbit that they're going to be using for Artemis in the future. So that test was launched in June and has worked out quite well. When NASA launched Artemis in November, I noticed that there really wasn't that much attention given to it. I was very interested in it. I'm sure most NSS members were interested in it, but the rest of the country didn't seem to be interested at all. I noticed that on the three big TV networks, ABC, NBC, and CBS, they did not have it in the first part of their nightly news program. And in the New York Times, the next day, there was a front page article about it, but it was below the fold, indicating that it's not as that important as some of the other things. One thing that happened that was really interesting, at least for NSS people, is NASA has many missions around Mars. One of them, Perseverance, is carrying a small experiment called MOXIE, which is designed to use the raw atmosphere of Mars to generate breathable oxygen. So that means that when we go out in the future, we can live off the land, making our oxygen from the resources on Mars. And this was tested out this year and actually did really produce breathable oxygen on the surface of Mars with in situ resources. The big mission that got a lot of attention was the NASA DART spacecraft. And this was designed to divert an asteroid to prove that we can, in fact, strike it with a spacecraft and move it out of orbit. And thus, if it's threatening Earth, rescue the planet. And that took place. This picture is from the cameras on the spacecraft, just about 30 seconds before it actually crashed into the asteroid. And this is what it looked like close up. There was a small CubeSat that was actually taking pictures. The reason they picked this particular asteroid is that it is in orbit around another much larger asteroid. And this fact of being a pair in orbit around each other made it much easier to measure the change in the orbit of the smaller asteroid that they crashed into. And they were expecting about a 10-minute change in the orbit of the asteroid. They actually got a 32-minute change in the orbit. So they really did prove that what most physicists knew, if you hit something with a satellite, it will move apart. But not everybody's a physicist. And when they go to the funding agencies, they want to say, see, yes, we've done it. We proved it in the real world. Moving way, way beyond Mars and the asteroid belt, the Voyager spacecraft are beginning to shut down. They've been in space for 45 years. And this year, they actually had to begin turning off some of the instruments. Now, they had turned the cameras off decades ago. And they're powered by a radioactive battery, and that battery is basically running out. So by turning off some of the experiments, they hope to stretch the battery out to where they will reach a 50-year mark, which they think would be very nice, but they're not certain they're going to be able to do that. So in the next few years, if you hear that the Voyagers have fallen out of communication, you can be saddened by it, but don't be surprised when it happens. The really big attention was, of course, the Webb Space Telescope. And the Webb is a second-generation space telescope designed to be another generation of the Hubble telescope. Now, Hubble uses visual light, and Webb is actually in the infrared part of the spectrum. And it's been worked on for 30 years, and it was finally launched last year, actually on Christmas Day, on December 25th. So it was kind of a gift to astronomers and astronomy lovers everywhere on the Earth. And it was launched by the European Space Agency with their Ariane vehicle from their South American launch base. And after the launch, everybody should really hail Ariane 5. The rocket did its job so well that it doubled the lifetime of the Webb Space Telescope. Basically, the Webb carried a certain amount of fuel. Part of it was dedicated to mid-course corrections, so they could put it exactly where it was supposed to be. And the rest was for station keeping when it reached its final orbit. The Ariane 5 did so well that they didn't have to use very much of that station keeping fuel. Now it's available for use in the rest of the mission, doubling the lifespan from 10 years to 20 years. And in fact, if you're going through an article or a blog post that says that the Webb mission is 10 years, you know that it was written before the launch, because now it's a 20-year mission. It took them about a month to get everything arranged and get the optics aligned. And one of the things they discovered after they did this is that the Webb mirrors are so good, they are actually at the limit of the laws of physics. It's physically impossible for them to be any better. Basically, the optics in the Webb are perfect. And that was a surprise. Also was a surprise, they picked this star because it was alone in its area around space, because aligning the telescope with more than one light source would have been pretty hard. But once they did get it aligned, they noticed all these backgrounds. And these are actually background galaxies that the Webb telescope picked up, showing that the optics is better than we ever expected. Nobody expected there to be these background galaxies in the Webb was hit by a micrometeorite after it had been in orbit for a while. And while that's somewhat concerning, NASA did engineer the Webb. They realized that out in open space, there may be some hits, and they engineered it to endure these hits. So while there's at least one, it hasn't really degraded the Webb instrument very much. In addition to looking out into the galaxies, you can use the Webb for pictures in the inner solar system or the solar system. And this is a picture that the Webb took of Jupiter in the infrared. And you can see the auroras and the great red spot and some of the moons. And in addition to doing that, they used the Webb to take a picture of the pillars of creation. That was taken in 1999 by the Hubble Space Telescope. And in fact, on this side of the picture is actually the Hubble picture, which is taken, as I said, in 1999. And then this is the Webb photograph of the same mission. And you can see the difference from taking in the visible light and the infrared light. The infrared light comes through the dust very much better. And another thing, this star here has 4 sort of spikes on it. That has to do with the optics of the Hubble Space Telescope. And in this one, you can see there are 6 spikes. That has to do with the optics and the arrangements of in the Webb. So now you can look at a picture and know immediately, is it from the Webb or is it from the Hubble? And impress all your friends. And the Hubble is beginning to wear out. It's been in space for over 30 years. And the last servicing mission was many years ago, 10 years ago. The Hubble has 10 gyroscopes, 5 gyroscopes. And they were replaced with the last servicing mission. They're now down to 3, which is the amount they need to keep pointing it. So there's some possibility that within the next few years, the Hubble may lose the ability to point as well as it has. This inspired this gentleman, who was a space enthusiastic billionaire, to propose to NASA that they use SpaceX vehicle to go up to the Space Telescope and lift it to a higher orbit and maybe make some repairs. NASA has that under consideration, but they haven't decided what they're going to do with it or not. Bizarrely, when the Apollo astronauts were back on Earth, NASA let them keep some of the equipment they used on the program, on their launches. And some of that equipment had very minor amounts of moon dust on it. And one of the astronauts got the idea of putting that all together and then selling it on the open market. Now, this was not a very large amount of moon dust, just as this headline says, just a pinch of moon dust. And there were a lot of lawsuits. But eventually the astronauts did win, and they were able to sell this very pinch of moon dust for $500,000 this year. Congress has instructed NASA to look into UFOs again. And NASA set up a panel to do that this year. And they announced the people who would be on the panel. However, the report from the panel won't be for another couple of years at least. Moving from the NASA programs, where we know how much they spend, to the military side of the US space program, where we know they admit to spending $15 billion, and we know that there is considerably more being spent, probably enough to bring the total up to about 50 billion. Now, most of that money is spent by the United States Space Force, which was formed a few years ago, and they have now consolidated most of the space spending in the Space Force. One of the things Space Force got this year was a theme song. And so you can go on the internet and listen to that theme song, but they don't give all that much information about the rest of their programs. One of the things they do have is the X-37B space plane. This is a fully reusable space plane. They actually have 2 copies of it, and they've been using it for various missions. It just completed its 6th mission on November 18th of this year, and it was in orbit for nearly 30 months. And you asked the Space Force, what was it doing? And they would say, studying the space environment. And that's all they said. So we're not sure exactly what they were doing. This just gives you some idea of what the X-37B space plane looks like. This is a picture of it on the ground. You can see this drawing. This is a man, and gives you a scale drawing of how big the X-37B is. And at the very bottom of this slide, this is also to scale, and this is the space shuttle and the X-37B. So you can see it's a much, much smaller vehicle, and it is launched on unmanned rockets. They announced that they were actually beginning to study the requirements for operating around the moon. And they haven't talked very much about that, but they are considering moving from the US military space program to what was at one time the largest of the space programs in the world, and that is the program of Russia. And the Russians do have now a fairly big space program, but not as big as it was. They are focused on the International Space Station, just as the United States was. And they have sections on the International Space Station, and they've been working just as American astronauts have been. They also have some programs outside the International Space Station. They have now the first operational launch of a new rocket that they've developed to replace their Soyuz rockets. And this is in May, and so they're going to be using that in the future. They have a Proton unmanned launch vehicle that they've been using for 6 decades. And they built the final one this year. And then next year, they will be phasing it out. Basically, it had some reliability issues, and they just couldn't compete in price with the Falcon 9. There is some private operations in space in Russia, and one of them actually succeeded in launching a small satellite just in December of this year. And there are other private space companies working in Russia. But the big event that happened for the Russian space program, and for a lot of other things in Russia as well, was the invasion of Ukraine. This war started in February of this year and caused a lot of difficulties, not just for the Ukrainians, but also in the Russian space program. And I just called it a war. If you were in Russia and you called it a war, you could spend 15 years in prison. And there are people in Russia now who did that, who called the special military operation a war and got long prison sentences. When it first started, we actually were able to use the private Earth observation satellites to look at what was happening on the ground in Ukraine. And this is actually a picture from one of those private companies, Maxar Technologies. And they release these types of pictures onto the internet fairly regularly. And when I started doing this 40 years ago, nobody would even admit that these pictures could be taken. And the only ones who could take them were a couple military programs, the US and Russia. But now they're available for many people on the internet. Another part of the space program that got attention with the attack on Russia, one of the Ukrainian ministers, the Minister of Space, actually tweeted Musk in February of this year, just after the attack started, and said, "You're talking about going to Mars. Why don't you help Ukraine?" And Musk tweeted back 10 hours later that the Starlink system, which we'll talk a little bit about later on, which is basically an internet connection from low Earth orbit, was activated, and he had sent ground stations to the Ukraine. And these turned out to be very, very helpful to the Ukraine from when they got it in February. In fact, by October, some people close to Putin were actually threatening to strike the Starlink satellites that were helping Ukraine. They are playing a major role in Russia's the Ukrainian military, and the Russians want to do something about it. Now, this warning was not particularly specific. They didn't specify what they meant by strike. It could mean just attacking the software that runs the Starlink system. It could also mean shooting the Starlink satellites down. Now, the Starlinks, there are many satellites. They started about 500 pounds, and they go up to the latest ones to about 2,700 pounds. And if you started to shoot them down, that could immediately create a lot of debris in low Earth orbit. And a single individual satellite being blown up would not create all that much debris since they're only about slightly over 2,000 pounds. However, you can't take out the whole Starlink system by just taking out one satellite. You have to take out many of them, maybe 50, maybe 100. And as you take out more and more, that begins to create more and more debris. If you've ever seen the movie Gravity, one of the premises there is that something sets off a chain reaction which destroys everything in low Earth orbit. If they do attack the Starlink satellites with their anti-satellite weapons, that could actually happen in reality. There were other sanctions that the Biden administration imposed on the Russian space program. It was designed basically to degrade that program, to hurt it, to punish it for the invasion of Ukraine. And it seems to have worked. It seems likely that the launch campaign that they were planning on had actually been cut by a third by these sanctions. And there are other sanctions as well. This lady is actually the first woman who ever went into space in the 1960s. I wasn't even aware that she was still alive. She is in fact 87. And she publicly supported the Ukraine invasion, so they put sanctions on her. Basically, it amounts she can't leave Russia at least to go to the United States or other countries. Russia, with its Roscosmos, which is the Russian equivalent of NASA, actually had a launch base in South America, the same place where Ariane 5s are launched. And they first suspended their operations, and then after that, they completely canceled them, and they no longer have this launch base in French Guiana. Europe severed the programs, its connections with Russia about unmanned moon programs, and they also had a program to go to Mars called ExoMars, which was going to be launched by the Russians, and the Europeans have pulled out of that. China announced that it was halting its science cooperation with Russia, and they weren't very specific exactly how much they were cutting off, and they said also paused it, so they may resume in the near future. So this crisis really could sink the International Space Station. When it first started and the first sanctions were announced, the Russians actually threatened to pull out of the space station then, the same week. And they actually put out a video of a simulated video of the Russians leaving the space station, and they're closing their section down. However, they didn't go through, at least so far, with that threat. They have said that they're very skeptical about extending the lifetime of the service contracts from 2024. Right now, they are committed to staying on the International Space Station to 2024. And there's, as I just said, they're very skeptical about extending it beyond that. And there was a crew exchange program where an American astronaut goes up on a Soyuz and a Russian cosmonaut goes up on a Crew Dragon, and they canceled that. Then they reinstated that. And not, at the present time, it is reinstated, and it was used just recently. So once the astronauts and cosmonauts are on the space station, they really stay away from talking anything but their work right in front of them, work on the space station, and they don't talk about the war in Ukraine. It almost came up, though. One of the Russian replacement crews came up with in coveralls that actually resemble the colors of the Ukrainian flag. And a lot of speculation went on, are these guys protesting the war? And if they are they planning to spend the rest of their lives on the space station or go back to Russia for a 15-year prison term? However, it turns out that those coveralls were actually just the colors of the universities that all three of these astronauts extended. So they were basically being alumni, promoting their school, and really didn't have anything to do with the Ukraine war. So NASA, Russia has been talking about, we're going to be on, we're staying by 2044, and they keep changing the date. Then after a few days after they announced 2024, they said, well, maybe they'll wait until 2028 because they estimated that that's when they will have their own completely separate space station built and operational. So there was even some suggestions that maybe these announcements were just a tactic to gain some funding for that new space station. So as it stands now, Russia is committed to the space station till 2024. And it looks like they're going to fulfill that commitment. But depending on how the war goes, they may actually pull out earlier than that, or they may stay longer. Moving from Russia to another Asian space power, and that's China, which has the largest or the second largest space program in the world. And they have a full set of programs, both civilian and military. And they are actually competing with the United States pretty vigorously. In September, they actually announced that they are launching unmanned missions, or plan to launch unmanned missions to Jupiter and Uranus. And the US is also planning probes there. So it's sort of, see, we're competing with you. But the main focus of the Chinese space program this year was their own independent space station. And they launched the core module for that in 2021. And this year they launched the other parts of it. They have been using the space station since the core module got up. The cargoes have been unloaded. The takonauts are doing spacewalks and carrying out various procedures around the space station. In July of this year, they launched the second capsule, the second large module to the space station. And that went off quite well. And they got back to it's now attached to the space station. But they use a 23-ton rocket to boost these labs to the space station. And they have no way to control how that spent rocket booster actually lands on Earth. So there was a lot of worry after they had successfully launched the lab module. Where is this space booster going to fall? And luckily it did land somewhere over Malaysia in the Indian and Pacific Oceans and didn't cause much damage on Earth. And then again, in October, they did the same thing. They launched a third and final module to their space station. And they used the same 23-ton booster. And again, they had no way to control where it was going to land. And again, they lucked out. If that out of control booster landed in the Pacific Ocean, there was actually some talk about airspace closures in Europe because they were afraid that the booster would fall through European airspace, but it didn't. So twice this year, they lucked out and the booster landed harmlessly in the Pacific or the Indian Oceans. And at the very end of last month, they actually had the first crew rotation in the nation's history. The space station is now complete and they've rotated one crew. And this is the kind of thing that they do on the International Space Station. So now they have an operational space station with crew rotation in China. They are also planning to send men to the moon, and their current target is 2023. And they are working pretty hard on it, and they probably will succeed, I think. They have a military program, just as the United States and the other major programs do. And the big thing in this program, they have created a satellite that instead of blowing up an enemy satellite, actually docks with it, wraps itself around that satellite like a python, and then squeezes the enemy satellites to destroy them. Now they have built a prototype of this, but they still haven't tested it in space yet. But that does show you that they are working on military stuff as well as civilians. Moving from China into another Asian space power, and that's Japan. Now, Japan also has a complete space program with all sorts of manned components, rockets, and other things, unmanned probes. This is the Japanese rocket, the H2, which is what they're using now. And they have the H3 in development. The H3 is basically designed to lower the launch costs, and they hope that it will be a success in launching commercial satellites from around the world, in addition to any Japanese satellites they want to launch. And they had some delays with this spacecraft, or this launcher. In January of this year, they had to announce that they're having some problems with their main engines, and they still haven't resolved them, but they are apparently planning for the first test launch sometime early next year. And this is their the manned part of their program. It's a capsule or module on the International Space Station, which has been attached now for 10 years. You can do experiments in shirt sleeves. It has a small airlock, which has actually been used to launch some CubeSats from the space station. And it cost them about $1 billion when they put it together. Now, there is also private companies in Japan working on space, and probably one of the most interesting one is this company called iSpace, and they have developed an unmanned lander on the moon, and its purpose is to take experiments from universities, from companies, for anybody basically who wants them. You can either rent the full payload capacity or just parts of it for your experiments and get it taken to the moon. They were planning to launch these, as this slide says, in November or December 9th and November 15th. They delayed it to November 20th, 22nd. They now had to delay it again. And the current schedule is sometime within the next couple of weeks. They haven't set a really firm deadline, but within the next couple of weeks, you will see a Japanese private mission launched to the moon, and it will be launched on the Falcon 9 booster. So it will be a private commercial launch to the moon with a private commercial flight or lander. And that wouldn't have been happening 40 years ago either. Moving from Japan to another Asian space power, one we don't usually consider when we're talking about space programs, but India does have a very large, very successful space program. And they have a full set of boosters. This slide was made for the Indian market. So this HM Ambassador car is actually a small subcompact, weighs roughly a ton. So that gives you some idea of how much payload these can put into orbit. Mars, India had a mission around Mars, an unmanned mission around Mars. This actually lasted 8 years. But then in October of this year, it basically fell out of communications, and that ended their first interplanetary mission. And they are planning others as well. And India's space ambitions were really hurt by the COVID-19. They do a lot of good work, but it's a fairly small central organization, and the pandemic really cut down into their work time. In particular, it delayed their first manned space mission. India does have a plan to put 3 Indian astronauts into low Earth orbit on an Indian-built rocket and an Indian-built capsule. And this was originally actually scheduled for last year, but they had some technical delays, and then COVID hit. And now it's been delayed somewhat more, but they are still working on it. And in fact, the Russian war also is affecting this area. The Indians actually get their cosmonaut training facilities from Russia. They lease them from them. They get their spacesuits from Russia. And they've had a lot of other help from Russia. And it's not certain exactly how this Ukrainian conflict is going to be affecting that. But they do hope to have their first manned mission in 2023, probably later in the year. So if we do this again next year, we may be talking about a manned Indian mission to Earth orbit. Moving from Asia to Europe, the European Space Agency is actually a collection of 27 European countries. It started in 1975. They realized back then that individually, Great Britain, Germany, France, individually could not compete with the United States and Russia. But if they pooled all their efforts, they could become a very significant player in the space programs. And they have actually succeeded in doing that. We mentioned the Ariane 5 launched the Webb. They have a program with Ariane 5 that has been used to launch many commercial satellites. And until SpaceX came along, it was actually the most successful commercial launcher in the world. And they are now planning, partially in response to Falcon 9 and SpaceX, an advanced version of Ariane 5 called the Ariane 6. And they had originally planned to launch that this year, but they had to delay it probably into early next year, or maybe mid next year, depending on how they work out the various problems they're having with it. Japan does have a manned component to its space station, which involves the International Space Station. It has the Columbus module, which has been attached to the International Space Station now for over 10 years. And that's a shirt sleeve environment where you can do all kinds of various experiments. And they've been using it steadily for 10 years. They have a robot arm on the space station, and they actually improved it, added a control panel to that arm. And so this arm is in addition to the Canadian Space Agency's arm at the space station. And ESA had some pretty extensive programs with Russia. We mentioned moon programs, and this is a picture of one of the Soyuz being launched from French Guiana. However, that program has now been ended, and they're not sure how they're going to get their ExoMars unmanned rover to the surface of Mars. They're talking to Japanese, to SpaceX, to basically anyone who could possibly launch it for them. Moving from the space programs of nation states to the commercial private space programs, where these are companies that want to use space to make a profit. And there are quite a lot of them. And there are some estimates that there will be $1 trillion economy in space within about the next 10 years. And these companies want a part of that industry, of that orbital industry. The fastest growing part of that industry is Earth observation. And in fact, most of the 72 small national programs I mentioned are actually, in fact, Earth observation programs with one Earth observation satellite per country. They have also been used for monitoring conflicts and all other such of things like the war in Ukraine, which is also being done by private companies. Moving into manned private operations, the Axon company actually had a mission, the first private mission to the International Space Station. And NASA, as we mentioned, wants to have commercial space stations. And so this Axiom is a company that's developing those and is launching commercial satellite manned missions to the ISS. They do this by leasing the Crew Dragon from SpaceX. And the mission was quite successful. They were up in April, and they actually had a problem, not with any of the equipment in space, but on the ground. There was a hurricane passing through their landing site. So they had to stay on the International Space Station for 4 extra days. I'm sure that very much upset the private astronauts that they had to stay 4 extra days. But the mission did end safely at the end of April, and they splashed down near Florida. And Axiom is planning more missions like this one. And there is a completely separate manned private space program. This gentleman we mentioned in regards to repairing the Hubble, he has actually chartered 3 more manned space flights from SpaceX, again using the Crew Dragon. And he had one mission in last year, and the next one, they're calling the whole thing Polaris, and the next one is called Polaris Dawn, and that's scheduled for sometime in March of next year. And on that Polaris Dawn mission, there will be, they plan and hope to get a private person out doing a spacewalk. So this will be the first commercial private spacewalk in the history of the world. SpaceX, the company that's been leasing all these capsules to Axiom and to Polaris Dawn, actually is not itself a space tourism company, but they will happily lease them to anyone with the money. What SpaceX is working on most now is the Starlink satellites. And Musk's plan is to use the money from these internet satellites, which will be in low Earth orbit, connecting the whole Earth to the internet at one time. The money from that will be used to bankroll his explorations of Mars. And will he be able to pull that off? We don't know. They've been launching these rockets steadily with their Falcon 9. And this year, they actually lost 40 of the satellites. They launched 40 of them. There was a geomagnetic storm just after they had launched, before they had gotten the satellites into the proper orbit. And that storm screwed up the software on the satellites. And so they all came crashing down. One of them actually came down in Australia. And the farmer who found this, when he first started walking up to it, he thought it might be a dead tree and was very surprised to find that it was actually a piece of a satellite. Starlink satellites have been causing some concern because they are causing streaks and asteroid hunting telescopes. So the professional astronomy community is a bit worried about not just Starlink, but all the satellites that have been putting up. Are they going to cause some problems with professional astronomy observations? And NASA did buy 5 more Crew Dragons so that they will have enough capacity to keep the space station operational to 2030. SpaceX also has a very large rocket called the Falcon Heavy, and they tested that a couple of years ago, and they haven't launched the Falcon Heavy since. Now, there's no problem with the Falcon Heavy itself, but the capsules, the satellites they were scheduled to launch were having some problems. Most of them were military, so we don't know exactly what the problems were, but they're beginning to take those out. And so Falcon 9 had its next launch, and there will be others coming up. SpaceX is working also on its Starship, which is designed to create dirt cheap space travel. This is just one of the prototypes on the pad, and this will be fully reusable, gives you some idea of its size. And this chart just shows you the size of the Starship compared to many of the other rockets that have been used, the Saturn V, the Space Shuttle, and it gives you some idea of their launch capacity. As you can see, it actually has to low Earth orbit, a larger launch capability than the Saturn V. And they have a contract with NASA involving the Artemis program. Artemis will use the upper stage of the Starship to take the astronauts from low lunar orbit down to the surface of the moon. And they actually had a contract for a second Artemis lander. The first one would be used in the Artemis 3 mission, and then the next one would be probably Artemis 4. SpaceX, as I said, is not a space tourism company, but they do have a couple of space tourism flights on their schedule. When when Starship is operational, they intend to use that to do a circumlunar mission around the moon, basically duplicating the Apollo 8 mission. And they sold the first one to a Japanese billionaire who is taking along 8 artists with him. And they sold this before they actually started development of the Starship, because they didn't have the money to really get started. So they used the money that this billionaire paid them as the beginnings for the seed money for the research for Starship. And they now have sold tickets on a second mission around the moon. And that one hasn't not necessarily filled up at this point. So Musk believes that with the Starship and with the Starlink, he will be able to get humans on Mars within 10 years, according to him. Now, this was before he actually bought Twitter, spent $44 billion on what was not a $44 billion company. And so how that's going to affect his plans for Mars or the Starship is not unclear at this moment. The other big private space company is Blue Origin. Blue Origin was founded by Jeff Bezos, the founder of Amazon, and it's his private space company. And Blue Origin has been sending astronauts to suborbital space for since last year, and they've had several launches. And then they also use the rocket as a sounding rocket with just experiments on board. And in September of this year, something went wrong with the rocket. It basically blew up. The capsule had to separate from the booster. There were no, as I said, there were no people on board, just science experiments. And the capsule actually landed safely. If there had been any people on board, they would have had some bruises and it wouldn't have been a fun ride, but they would have survived. And the program now is suspended until they figure out what exactly went wrong with the booster. Amazon also has some other projects in the works, And that's what they call their Project Kuiper, which is their competition with SpaceX Starlink. And they this year signed contracts to launch this project into space. It signed up for 83 launches from various space companies, Arianespace, which is from the ESA, their own space company, United Nations Launch Alliance, which is an American private launcher. They're getting 38 launches on the Vulcan UAL launchers, 18 on the Ariane, 12 on the New Glenn, with options for more. The plan for the Kuiper is to put 3,236 satellites into orbit by July of 2026. So you can see they do need a lot of launch vehicles for this. They are also working on a commercial space station called Orbital Reef, which they would be launching in the 2030s. And this is one of a number of private space stations that are being worked on. They're in the early beginning stages. Turn in next month for the forum to learn out more about them. And Virgin Galactic actually succeeded in getting a suborbital launch before Blue Origin last year as a kind of competition. However, after that, they have been having some problems with the technical side, and they've also been having problems with money. So Virgin Galactic hasn't flown anything, and the prospects are that they're flying anything soon are rather small. We mentioned Starliner earlier, actually getting to the space station 2 years after the first visit. And the contract Boeing signed with NASA said that Boeing had to eat any cost overruns. So the Starliner has now cost $900 million more than they expected. And Boeing has actually had to eat the costs for that $900 million cost overrun. And when they get it successfully tested and manned, it's going to be a big deal because Musk is now going to have some competition with the manned space programs, and people will be able to rent either from SpaceX or from Boeing. There are I mentioned a lot of other companies or small programs, and they're just too many to go over very well because basically we have some time constraints. To sort of symbolize all of those various programs. Firefly is a small launch company, and they actually did succeed in getting a small payload into Earth orbit. And there are several other companies that have actually been successful in getting launches of very small satellites into Earth orbit. One company with a space program, one country with a space program is Israel, and they have their own launcher, and they've put up some satellites of their own. But the big news in Israel this year was an Israeli-based billionaire. Apparently he made his money in software, actually rented or leased a Falcon 9 for an entirely Israeli mission to space. And that means that there are two continuing private manned space programs, the Axiom programs and the Polaris program, and this one-off, and there's certainly the possibility of other one-offs anyone who has the money can rent from SpaceX and eventually from Boeing to put a man in space. In fact, if the National Space Society could raise the funds, we could lease a mission for the Crew Dragon. And then we could have it at the ISDC, we could have a contest to see who is going to be the person who rides that satellite. And I'm sure very few people would walk out of that conference alive. But that gives you some idea of what has happened in space. Has to go over just the highlights because there's so much happening. And that makes my job creating a review really hard, but it's very good for the space program because it means it's spreading out and more countries are using it. And it's becoming an integral part of the world's economy and the building toward a civilization, a space-going civilization. So at this point, if there are any questions, I'll try to answer them. Let me take care of that.
Cool, thank you, Larry. We've got some questions that had been asked by people at the time they were registering. I've gone ahead and answered a number of the questions that were asked via the chat, but we're still going to take more questions. So if you have a question about some topic that Larry addressed, please go ahead and ask it. I'm going to start off, though, with a couple of questions that we did get from folks at the time they registered. One I'm going to answer is, what are the prospects for commercial building of space stations? I would encourage you to sign up for when the registration information is available for the January 12th NSS Space Forum, the subject of which is going to be the NASA Commercial LEO Destinations Program, and it will be a Space Ambassadors presentation. In addition to discussing the NASA project itself, we'll also be addressing each of the companies and their designs that were awarded contracts as a part of the NASA CLD program. Still on the subject of space stations, Larry, one of the questions that was asked was, do you think that the Chinese will ever internationalize their space station?
They certainly want to have international astronauts go to the space station, and they want cooperation on their space station. And just recently, they actually announced plans to begin expanding it, putting up another core module and a couple of other modules. And they have discussed with the Russians actually putting a Russian lab module onto the Chinese space station. So they do want to do that. It's in the early stages right now, but that very well could be happening in the future.
On a related note, since you can't have a space station without having a way of getting back and forth to it, another question that was asked was, do you have a best guess for when the Starship launch will happen?
Scheduled for next month. I checked the website and they just said in January. They did not specify a particular date. My impression was it'll probably be the end of January, but the current plan is to have the first orbital test launch in January.
Another question that was asked via the registration process was, how do the economics of the SLS program make any sense going forward?
The cost of the SLS launch is $2 billion at each launch. And to compare that, the Falcon Heavy is only about $200 million. So they can't get all the way to the moon. But that makes it very expensive to run this program. And when the Starship is finally operational, it's going to be a lot cheaper. So the commercial economics for the SLS is really very poor. But it does have a lot of support in the Senate and in Congress. So I think it will continue to be launched, but it won't be commercially viable at all in the future.
Yeah, nor is I wouldn't say it's viable now, but given that the current NASA administrator was one of the key senators in pushing through approval of SLS, it certainly seems that SLS, it would not have been acceptable for that spacecraft not to launch, but whether or not NASA can continue to maintain it, since arguably a single SLS launch costs more than NASA spends on ISS in a year. So SLS is a great subject of debate in the space community due to the cost and delays.
I noticed that we got question in the chat that the NASA IAG had estimated $68 million for an SLS launch. NASA has been lowballing the cost of the SLS for a long time, and that 68 million ignores a whole bunch of costs. So
I haven't seen anyone legitimately, say, attach $1 million figure. I've seen estimates anywhere from 2 to over 4 billion per launch. And I would suggest that you'll see a similar discrepancy, let's say, in terms of what does a space shuttle launch cost. And people still argue about what it cost the program, even though the program has wound up. We know exactly how much it was spent through development and operation. Divide by 135, you've got your cost. That is still an open issue, because if you try to prorate out the development costs, which one figure I heard was that for the SLS Orion combo, we're talking $60 billion to get to the point where we've finally gotten one mission launched. So
Jim, Larry, that chat question actually says 6 billion.
6 billion. Okay.
Yeah. Okay.
Quickly.
Now, related, we've talked about SpaceX and Falcon Heavy, Starship, and SLS. Another one of the questions we got was, is it a good idea that different countries are launching their own rockets into space?
Absolutely. Space, to get a spacefaring civilization, you have to spread it out. And the more people who are working on it, the more programs there are, the better it is for the long-term goal of the National Space Society, which is, of course, a spacefaring civilization. So the more people involved in doing that, the better.
Okay. Now, you did talk briefly about Mars in your presentation. One of the questions was, what about Mars? Curiosity, end of Insight. Was there anything about Mars that you had to edit out of your presentation for time constraints?
There were a few things. The InSight lander, which has been on Mars for a couple of years now, several years, and it is basically running out of power. It's a solar-powered craft, and it's on the surface near the North Poles. And they had hoped that the winds on Mars would blow the dust off, but that doesn't apparently happen in the polar regions, only in the equatorial regions. So they'll probably be closing down InSight, actually probably next month or in February. It did return a lot of interesting data. It actually recorded a meteor impact on the surface of Mars, and they were able to use the InSight data to have one of the orbiters pick out where that new crater was. So, and Perseverance is we mentioned the MOXIE experiment, and Curiosity, they're still working, still going strong. So,
oh, to satisfy my curiosity, I'll throw a trivia question out there. Do you know how many countries actually have active missions at Mars at the moment?
oh, well, there's us, the Chinese, the Europeans, and India did have one, but it died in October. So that's like 3 or 4. The European Space Agency has had one as well. So how many? The European is one agency, but it's 27 countries. So how you count that is an interesting point.
Okay. One of the questions that was asked online was, why deorbit the ISS? Why not put it up into a storage orbit?
Money. That's basically what it would cost to move it up to a storage orbit. You'd have to attach a fairly substantial booster to move it up much higher, and the putting it down into the ocean, the booster is a lot smaller and therefore cheaper. Also, the ISS was never designed to last forever. And the solar panels, which have been up for several decades now, are wearing out. So even moving it into a storage orbit, it still wouldn't be of particular use. It would be hard to make it useful. So they feel it's better to just put it down.
Okay. One interesting question that was asked, could any of the 2022 activities have an impact on future space solar power activities?
There were announcements like this. We mentioned NASA announcing that they're going to be restudying it. And apparently the Chinese are planning some kind of actual test in space of a solar panel that would beam microwaves to another satellite in low Earth orbit, just as a proof of concept. But they haven't so far, as far as I know, done that, but they are planning it. So that's something that's going on.
Okay, here's an interesting question. Again, not quite on the topic, but interesting nonetheless. With the change in our climate, how will space exploration have an impact in improving our planet Earth?
Monitoring. From orbit, you can see what's going on in the environment. And that lets you say, here, there's a problem right here. And so you can begin addressing it. As an example, there's a treaty forbidding the manufacture of hydrofluorocarbons because they damage the ozone layer. And once they were closed off, the ozone layer started actually to heal. And then a couple of years ago, it started to reverse. And they realized that someone was illegally manufacturing hydrofluorocarbons. And they used space assets to locate it in China and get that illegal plant closed down.
And I would point out to people that the scientists who made that initial discovery about the CFC chemistry and its interactions with ozone were the same scientists who were previously trying to understand the ozone chemistry of the atmosphere of Venus. And it was those insights that helped them to recognize what was going on with our own planet. And the same is true of studies of the climate on Mars in a science called comparative planetology. Mars is a heck of a lot easier to model than Earth because it is such a much simpler system. So all of the advances we have in space are linked to our being able to more effectively study our own planet, particularly as you bring down launch costs. It makes it possible for smaller science organizations to launch their own dedicated Earth observation missions. And let me see. One question. Did you what goal? I'm not sure how you want to handle this one. What goals were not achieved in 2022? So were there any major program cancellations that you were aware of, or major delays that happened, things that were scheduled for 2022 that
ESA's ExoMars, which was supposed to launch, but they had to cancel. But well, they didn't cancel the whole program, but without a Russian launcher, they have to delay that. There's a mission called Psyche, which was scheduled to launch this year, which was going to explore an asteroid. And they're having some real problems with the software in that. So they had to delay that for at least a year. And so those are NASA goals that were delayed this year. And the other countries, there are so many of them, whose goals? Those were NASA goals, but Russia actually obviously had some real problems with the sanctions cutting into them. And the Chinese don't announce their failures very much. So there are a lot of things going on, and there've been some delays, but it's hard to keep track of them because which is hopeful for a space-faring civilization. But there's so many entities with so many goals, it's hard to pick out which one is succeeding, which one is failing.
One other question, and I confess I don't know the answer to this one, and that's a good thing because it illustrates the progress we've made in the last decade. What is the change in the number of humans in space in 2022 versus prior years? And what do you see for 2023?
There will be continuing more people going into orbit and suborbital once they get Blue Origin figured out. But I went on the internet and found several different estimates of how many people have gone into space. One was 653, another one was 628, and there were a few others as well. Basically, the definition of space is on question. And it was about 20 or so people who went into space, maybe at the broadest definition in 2022, but on a narrower definition, it was smaller. And I think that's going to continue into the future because people can't quite agree exactly where space starts. So they don't actually agree who's gone into space and who hasn't.
Yeah, so maybe we should look for another step up circa 2027, 2028, when potentially one or more commercial space stations will come online. So we could conceivably at that point in time, perhaps have up to 5 space stations operating in orbit. So wouldn't that be grand?
Yes.
One more question we've got here that just came in. Interesting question, Carl. Since we are a competitive species, wouldn't many national space programs create a contentious competition in space?
Yes. And I had the slide about China announcing missions to Jupiter and Uranus. About the same time, the US started contemplating a Uranus trip. So yes, there's a lot of competition. And frankly, as long as it's kept within bounds, competition is a good thing. So a lot
if I recall correctly, I believe that NASA announced a number of potential Artemis landing sites circum South Pole.
yes.
And didn't the Chinese also announce that they were interested in sending missions to a number of those same sites?
To the South Pole. I don't know if it's exactly the same sites, but they have discovered water frozen in the some of the craters around the South Pole of the moon are constantly in darkness. And in those dark craters, there is frozen water, which is accumulated over billions of years. And that's a great resource once you get back to the moon. I mean, I mentioned the MOXIE experiment with oxygen on the Mars atmosphere. This ice is a in situ resource, something that you can use to live off the land. And that's why both the US and China are aiming to land in that general area so that they can explore and see how much water ice there really is in the poles, in the craters.
Okay, I just looked at my clock. We were supposed to finish up at like 9 and it's, well, our time 9 and it's already like 9:25. So Bert has been very generous in letting us go quite long with the Q&A. So Bert, I thank you for that because we had a lot of great questions and there's still more questions. Fortunately, I was able to answer a lot of the ones that were presented in the context of the chat or the Q&A. So Bert, what's your call?
Yeah, there were some really great questions and dialogue, so I figured let's just let it go on. But maybe see if there's just one or two more, and then we can call it an evening.
Okay.
Yep.
Well, now there was one that pertained directly to one of the slides in your presentation, Larry, and it was about, is there any more news about Russia's future commitments to ISS?
There's actually a lot of it, and it's not clear what's coming from the Russian government, what has the approval of the Russian government, what is just some people who are angry about the sanctions putting out to say, we're leaving, and the Russian government may not be saying that. So it's really hard to answer that question, because I think that the Russian government really hasn't made a final decision on it. And so there are people lobbying the government by putting out different estimates of when they're going to leave, and hope that that will force the government to make some kind of final decision. So right now, I don't know. And I don't even believe the Russians know, so for certain. So that's something we have to wait for the future to find out.
Okay, do you think it's, well, I mean, I would tend to think it would be a net negative for their space program. I don't know if they would look at it the same way, and if they have sufficient clout within the new Politburo to have their voice heard.
Actually, it depends to a certain amount on how the war in Ukraine goes. The Russians have been getting their butts kicked for the last couple of months, and that makes them angrier and angrier. And if that continues, they're going to be looking for some way to really, really show their anger. And pulling out of the space station might be one way to do that. And so it really depends on what happens on the ground in Ukraine, and also in the political councils in Moscow.
Just think of what this situation would be like if we did not have a commercial cargo and commercial crew program that left us totally dependent on Russian launch services to resupply and staff ISS.
That would have been hard. So, but luckily we don't have that, so.
Right.
Very good.
Great.
Should we call it an evening, gentlemen?
Yes.
Okay. Well, first, I really just want to thank you, Larry. That's just an amazing presentation, the depth and breadth of information you provide. And I love the way you incorporate the newspaper headlines. It makes it so interesting. So thanks again for a great presentation. And we definitely want to take you up for coming back again in 2023. Yeah. Sounds good. Great. Sounds good. Very good. And Jim, thank you so much for moderating. A great job. We really appreciate it, because again, your knowledge as well adds to the ability to ask the right questions at the right time. So thank you so much. As always, I would like to thank my two other NSS colleagues, Fred Becker, for the support on the tech side, and Larry Ahern for the support in developing the Space Forum program and helping us make sure we've got great presenters. So everybody, thank you. I'm just going to share my screen one last time to close out the session. There we go. If I can get everything to work here. There, okay. Oops, there's the chat. I think my mouse is dying here. Yeah. Nope, it is not working. I'm gonna just, there we go. I thought I had it. Okay, this is just our typical last slide, everybody. So again, thanks for joining us for this final Space Forum of 2022. We will see you again in about a month as we move into 2023 on the 12th of January. As both Jim and Larry mentioned, it's going to be a really interesting discussion about those low Earth orbit destinations that are being worked on. So everybody, again, have a great evening for those in our time zones, a great day if you're in tomorrow's time zone, and of course, a great weekend as we head into the holiday season. Be healthy, be safe, enjoy everything, and wishing everybody a very, very happy new year. So stay safe, and we'll see you next year.
Yeah.